Hey everyone, Sebastian here, back again, doing another core class video, this time on inferences from sample statistics and margin of error. I'm going to show you where you can find other videos I've done on this topic, and then we'll go from there. I now have a Substack I'm running, and in it, the post I have right now is charting all the different types of questions on the College Board. So if you know all these questions, you'll know how to do the test perfectly. So far I've done a full walkthrough on evaluating statistical claims, observational studies, and experiments. And I've also done a walkthrough on probability and conditional probability. And right now you'll see the video that is for 1 through 15. So I'll put a link in the description for this chart so you can look at everything I have. It's not complete yet, but it's getting there. And there are 22 questions on inferences from sample statistics and margin of error. And there are 15 types. So if you know the 15 types, you'll know any type of question in this category. All right, so let's get to that. We'll start with easy level, right? This is category A within easy, which is about estimating from a percentage and population size. And then we'll go from there. So here we have, there are 360 basketball players in a league. A sample of players was selected at random and asked whether they intend to do a basketball summer camp. Of those surveyed, 30% said they intended to enroll in the basketball summer camp. Based on this survey, which of the following is the best estimate of the total number of basketball players in the league who intend to enroll in the study program? So we have 360 basketball players in the league and 30% said they intend to enroll. So this one's not too bad. We just do 30 over 100, or you could do it as a decimal, times 360. And that's going to simplify to 3 over 10. We can take this out and take out another 0, so the bottom is totally out, so it's just 3 times 36, and that will be B, right? So this is taking a percentage in population size and using that to find a predicted value. So pretty straightforward. It's in the easy category. There's just two numbers. You use the two numbers, you multiply, and then you go from there. So we'll go on to a next question, which is still in the easy category, and it is going to be, I label it as FEREB. In this one, we have a school has 60 12th graders. A random sample of 25 of the 12th graders is surveyed on their opinion of a new school gym. It's found that 15 of the people surveyed opposed the new gym. Based on the sample, which of the following is the best estimate of the number of 12th graders at the school who opposed the new gym? So we want to know 12th graders who opposed the new gym. There are 60 12th graders, right? A random sample of 25 is surveyed. It's found that 15 opposed the new gym. So it's still easy. There's more numbers, but it's still not too bad. So 15 out of 25 opposed the new gym. And you can set that equal. You can make a proportion and say 60 is the total. So how many oppose, right? We'll do this. I would simplify 15 out of 25 first, and that'll be 3 over 5. Then you are going to multiply by 60 and divide by 5. So you'll get 60 times 3 over 5 equals x. You could cross multiply, but you don't have to because the x sort of gets left alone naturally. 60 divided by 5 is 12. So we have 12 times 3, so x equals 36. Okay, so again, you use the numbers they give you. You just sort of have to keep track of what each number stands for, right? 60 is the total. 25 is the survey, 15 is the people who oppose it within the survey, okay? So we'll go to the next one, which is still easy. This one's similar to the last one, except instead of a percentage, we're given values that we find. We could have found a percentage, but we could just use the proportion. Okay, so this is the third category of still the easy level. A certain company has 354 employees. To estimate the number of pens at the company, a statistician randomly selects 6 different employees and determines the number of pens each employee has. The number of pens in the random sample are 12, 8, 15, 10, 12, 9. Based on the mean of the sample, which of the following ranges contains the best estimate for the number of pens at the company? So these are the values for each of the 6 employees. So what you can do is you can find the average. So when you sum this up, you're going to get 66, right? And that was out of 6 people, so that'd be 11 per person. And then there are 354 employees, so you could do 11 times 354, and that's going to give you 3,894, okay? So that's what we can infer, right, from the sample statistics. And what is this range going to be in? It's going to be C, right? Very close to D with the 3900, probably a little closer than most questions on the test, right? Because I'm not copying these questions, I'm making them up to sort of get at the heart of the question. But you would go with C because that's the range it fits in, okay? So a little bit more involved than the first two, but still an easy level question. You find it per employee and then you multiply it by the number of employees. The numbers are still all being used to help you. There's nothing tricking you about the numbers. And now we have still easy category D, which is about making an inference when margin of error is given as a percent. So at a convention of superhero impersonators, 200 impersonators were selected at random and asked in a survey about a material for costumes. The 200 impersonators completed the survey. It was estimated that 20% liked the material with a margin of error of 4.5%. Which of the following is the best interpretation of the survey results? So this is just about knowing the basics of margin of error. And the basics are that when you're given margin of error and mean, the margin of error is plus and minus the value they give you. So it's going to be 26% plus or minus 4.5%. So that's going to be 30.5%. And then when you subtract 4.5, you're going to get 21.5%. So you should fall somewhere between there, right? And there are 200 impersonators, but that I don't think is actually going to matter that much. The thing that matters is that they're random. So let's look at our choices. A, the percent of the impersonators at the convention who like the material is 26%. That's a little too strong, right? It could be around 26%, but it's not exactly going to be 26%. The percent of impersonators at convention who like the material is less than 26%. Could be less, could be more, so that's still not right. Plausible values of the number of impersonators at the convention who liked the material are between 191 and 209. Not exactly, because we don't even know the total, so that one's sort of irrelevant. And then D, plausible values of the percent of the impersonators at the convention who liked the material are between 21.5 and 30.5, which is what we got when we added and subtracted the margin of error, so it will be D. Okay, so this one, honestly, on the test, you wouldn't even have to do the math. You could just look at the answer choices and see A and B are too strong. C is not enough info and also probably too strong. But D, right, it just says plausible values. It's not even saying they're definitely going to fall in that percentage, because that's also not true. But there's a high likelihood that they would fall in that percentage. Okay, so now we'll go on to the next one. So this is FEREE. It's the fifth category of the easy level. Make inference. It's similar to the last one, except instead of giving a percentage as a margin of error, we're given a value. In a study, data from a random sample of a population had a mean of 53, with an associated margin of error of 3. Which of the following is the most appropriate conclusion that can be drawn about the population mean? So it'd be 53 plus 3 and 53 minus 3. That would give us 56 and 50. So again, it's not going to be less than 53 or greater than 56. It's not going to be it is less than 50 or greater than 56. It is between 50 and 56. So that's the most appropriate conclusion. And it's not necessarily that that's true, but that's our best guess, right? It could be 57, it could be 49, it could be something else, but there's a high likelihood that it falls between 50 and 56. That's what margin of error is telling us. So now we're going to our first medium level question, right? So we had 5 of the easy level. I think we have like 6 medium level, and then we'll have 4 hard. So in this one, we'll be given a percent again. A study was done on the heights of different types of trees in a forest. The random sample of trees were measured. The sample contained 120 Monterey cypresses, of which 25% were taller than 85 feet. So we have A, most trees in the forest were shorter than 85 feet. B, the average height of trees in the forest is 85 feet. C, approximately 25% of Monterey cypresses in the forest are taller than 85 feet. And D, approximately 25% of Monterey cypresses are taller than 85 feet. So Monterey cypresses are a real tree. They're mostly found on the West Coast. There's a lot by San Francisco. But what this is testing is understanding that because the sample is just focused on Monterey cypresses in a specific forest, that's all we can know about. We can't know about trees in general, so it's not going to be A or B. And then it actually can't be D because that's all Monterey cypresses, but we can know it about Monterey cypresses in the forest, so it would be C. right? And that's just because, different tree species have different heights and sizes, so that makes sense. And also maybe the forest is particularly healthy for the trees, or maybe it's particularly unhealthy. And in this forest, the monterey cypresses grow differently than they grow in other parts of the world. So wherever your random sample is being taken from, that's what you have to focus on this type of question. And it's less about doing actual calculations and more about understanding the logic behind statistics and sampling. And now we have another one here. A psychologist asked a random sample of parents how many children they had. Based on the responses, the estimated mean was found to be 2.5 children with an associated margin of error of 0.5 children. Which of the following is the best conclusion from these data? All right, so again, we have margin of error, and we're trying to make an inference from this value. So 2.5 plus 0.5 will get us 3, right? And you obviously wouldn't have to write this out. You could just do it in your head. It would get us 2, and it'd be pretty natural. So it is likely that all parents have between 2 and 3 children. I think the fact that it says all parents is too strong, so it's probably not A. It is likely that most parents have exactly 2.5 children. Just, that wouldn't work in any situation, but here I wanted to do it this way to point out the ridiculousness of it. No parents would have 2.5 children, right? That's a half child. You can't really have half a kid. It is not possible that any parent has more than 4 children. Again, not possible is too strong a statement. And then D, it is plausible that the mean number of children parents have is between 2 and 3 children. So it would be D, right? The mean falls somewhere between there. We don't exactly know because we did a sample. We didn't do everyone, but we can guess that the mean is somewhere between 2 and 3. All right. So again, it's using logic and the study of statistics to make conclusions from it. Not too bad of a question at all. These should be pretty quick on the test because there's not actually that much math to do. So it's just you want to understand how to do that quickly. So here we have the third category in the medium level questions. A sample consisting of 640 readers was surveyed at random. Based on the sample, it is estimated that 24% of all readers read poetry, with an associated margin of error of 2.23%. Which of the following is the most plausible conclusion about all readers? So again, we'll subtract and add 2.23. So 24 plus 2.23 is going to give us 26.23. And then 24 minus 2.23 is going to give us 21.77. And just looking at the numbers, you can almost guess, right? It's going to be B, but let's read it through. Less than 21.77% of all readers read poetry. Not exactly. We would think it'd be between. Evaluate. It should be greater. Between 21.77 and 26.23% of readers read poetry. Okay, that makes more sense. Since the sample did not include non-readers, no conclusion can be drawn. That's not true. We can't make a conclusion about all adults, but we can make a conclusion about readers, right? So it's not that one. Since the sample included readers who didn't read poetry, no conclusion can be drawn. Again, it did include readers who didn't read poetry. So it's just going to be B, between 21.77 and 26.23% of readers read poetry. Okay, so you're getting the rhythm, right? You're seeing that there's a pattern to these. They're pretty predictable. You should be able to get all these right, at least on the easy and medium. And I believe even on the hard, but we'll get there. So then here's our next one. A store selling only socks has 10,000 different socks. To estimate the percent of blue socks in the store, a person selects socks at random. The percent of blue socks in the store is estimated to be at 11% with an associated margin of error of 1%. If B is the actual number of socks in the store, which of the following is the most plausible? So this is about finding plausible values when you're given a percent and margin of error. So 11% of 10,000, that's what we're going to do first. So it's going to be 11 over 100 times 10,000. We're going to divide the zeros out, so that'll go away. So it'll be 100 times 11. So it's going to be 1100. And then we have a 1% error. So 1% of 10,000 is nice and easy. We're just dividing by 100. So it's going to be 100. So we're going to add and take away 100 from 1100. So it'll be 1100 plus 100. So that'll be 1200. And 1100 minus 100, which is 1000. Okay, and that is going to give us A, right? So the other ones don't make sense, and this is just about knowing how to calculate margin of error from percentages into an actual value and calculate mean from a percent to an actual value and then work from there, right? So it's just like one more step than the other ones. That's why it's its own category, but it's still a medium level question. So we have FER, right? So it's medium level. This is the fifth category in it. A principal audits test scores at a school by taking a random sample of test scores and summarizing them. He sampled 60 scores from a recent calculus test and sees that 18 people earned A's. If 250 students took the test, which of the following is the most appropriate conclusion? A, exactly 18 students earned A's on this test. That wouldn't make sense, right? If 18 out of 60, you would think there'd be more A's. B, the best estimate for the number of students who earned an A on this test is 60. I think they're just taking this number, but we'll see. The best estimate for the number of students who earned an A on this test is 75. Okay, we'll see where we get 75. D, exactly 75 students earned an A on this test. So the way we would estimate, right, is you do 18 out of 60. You can set a proportion, right, equals x over 250. 18 out of 60 is going to give us, when we divide by 6, 3 out of 10. And then you multiply it by 250, so you have 3 times 250 divided by 10 equals x. And the zeros cancel, so it's 3 times 25, so you get 75 equals x. That leaves us with just C and D, which we sort of knew already, but it's not going to be D because exactly 75 students is too strong a statement. It's going to be C because it's the best estimate. Okay, so you want to know how to do the math, which isn't too bad, and then remember you don't say exactly because these are estimates and samples. You don't know the exact values. You have estimates and approximations and plausible values and likelihood. And now we have FERMF. So here we have a random sample of 150 townspeople are asked which hand they prefer to write with. No one in this town of 3,000 people is ambidextrous, can write with both hands. And everyone can write. Okay, that's just giving us background. Based on the table to the left, where the data are summarized, what is the best estimate of the number of people in the town who are left-handed? So it's split up by male and female, but it's just asking for people. So 52 plus 27 is going to be 79. And we're told it's out of 150. So it'll be 79 out of 150. And then we have 3,000 people, right? Equals x over 3,000. Again, you're getting the rhythm. You're going to multiply by 3,000. And you can do this without setting it up as a proportion if you feel comfortable with that. I'm just doing it to hammer home this idea for you all. But if you feel comfortable, right, if I was taking the test, I wouldn't bother with this. I would just go straight to the second step. 150 divided by 3,000 is going to be 20. And 20 times 79 is going to be 1580 equals x. And that is the best estimate, right? And this is about using a chart and using the chart to find an estimate from it. Okay, so understanding how to read charts and graphs is a big part of the SAT that I think a lot of students struggle with. Not so much that they can't do it, but it takes them longer than it should. So make sure you really nail that down. And now I believe we're going to move on to the hard level. So we have our first hard level. You can already see it's a bit more complicated. We have a chart. It's a bigger chart, but again, I believe you can nail this down pretty easily after some practice. In a study on maternal running habits, 240 randomly selected moms were asked how often and how far they ran. The data are summarized in the table to the left. Based on the data from the study, an estimate of the percent of moms who run daily and at a distance between 6 and 10 kilometers is 11.25%, with an associated margin of error of 1%. Which of the following is a correct statement based on the given margin of error? So we have this chart. We're actually given a lot of information that it's 11.25% between 6 and 10 kilometers, right? So who run daily and at a distance between is, So they run daily, so it's this people, right? So it'd be 27 out of 240, and they're telling us it's 11.25%, and normally you can trust them, but if I did the math on this, I would get that it's 11, it would be 0.1125. Okay, and then it has an associated margin of error of 1%, which isn't really going to be written here at all, so we just add and subtract 1%, so we have 11.25 plus 1%, 11.25 minus 1%, and we'll get 12.25% and 10.25%, right? Again, you wouldn't have to write this out. This is something you could do in your head, and I don't think you really have to check. They're pretty consistent about giving you these values and being accurate with them, and I think the chart is here almost just to waste your time and throw you off, but I wanted to show you that it does line up. So approximately 10% of moms run daily. That's not really what we're asking here, right? We're based on moms running daily between 6 and 10 kilometers. B, it is likely that between 10.25 and 12.25% of moms run daily in between this distance of 6 and 10 kilometers. So that really narrows it down, right? You're running daily, 6 and 10 kilometers. It's this that we were focused on. So it could be B, it probably is, but we'll check the others. There's a 1% chance that 11% of moms run daily and at a distance of 6 to 10 kilometers. No, they're not reading what margin of error means, and there's a 99% chance that 11.25% of moms run daily and at a distance of 6 to 10 kilometers. Again, not understanding the values, so it is B. And again, you could do this one without writing anything down. It'd be pretty quick, even though it's a hard level question. And as a chart, sometimes the chart is useful. If they give you the info, you don't have to work that out, and then you just work with the percents. So we'll go on to the next one. We have to estimate something where we're combining values and go from there. So a survey of college students at a university were asked their opinions on lowering taxes on the rich. The data are summarized in the table to the left. If the school has 20,000 students and the data is representative of the school, what is the best estimate of the number of students at the university who either strongly or somewhat oppose lowering taxes on the rich? So strongly or somewhat, I would fall into that category, but you would do 64 plus 35, and that gets you 99. And then if we add up the other parts, we're going to have 19 plus 31 plus 31, and that's going to give us 81, so plus 99. All right, and you could just use your calculator for this, but I'm working it out here as 180. So the proportion would be 99 out of 180, and you would multiply that by 20,000. And that would give us 11,000 students, okay? So that would be the best estimate. And sometimes they might not even say best estimate, even though it should be an estimate. But when they say it's representative, that's saying it's very accurate to the whole population, so you can just use that value. Okay, so for this one, it would just be 11,000. It's nice and clean. There's no answer choices. And it just takes a bit of adding and dividing to work it out. But you just have to feel confident about knowing what to do. And I think watching this video will help you feel confident. And always ask me questions if you still have doubts. So here again, you notice, right, that a lot of the hard questions all have charts. They like to have that in there either to read and give you info or to throw you off the scent. 3 random samples of townsfolk, ask them if they run as a form of exercise. The samples are selected from the same population and the margin of error is calculated using the same method. Which of the following is the most appropriate reason that the margin of error for sample B is greater than the margin of error for sample C and less than the margin of error for sample A? Okay, so margin of error for sample B, right, is greater than C, but less than A. Why would that be, right? Sample B had higher response rate than sample A and a lower response rate than sample C. Sample B had a larger sample size than sample A and a smaller sample size than sample C. Sample B had a smaller sample size than sample A and a larger sample size than sample C. And D, sample B is closer to 50%. So this is testing if you understand how margin of error is developed, right? And the way margin of error works is the bigger your sample, the more confident you are, and the smaller the margin of error. So it should be B. Sample B is going to have a larger sample size than sample A. That's why its margin of error is smaller, because you're more confident because you've done more data collection. But it'll be bigger than sample C because sample C had a bigger size. So the people who did that are even more confident. So this is an abstract conceptual question, no real math involved, just asking to see if you understand how margin of error and sample size are related. And then this is our last question, right? It's the fourth type of question in the hard level. In the town of Haines, 30 doctors at a hospital are surveyed. 33% say they don't have children. There are 30 hospitals in Haines, and the average hospital has 60 doctors. If the surveyed doctors are representative of doctors in Haines, which are the following best estimates the number of doctors who have children in Haines? So basically we're told that 33% of doctors don't have children. And it's asking for the number of doctors who have children. So that would be 67%. So if we have 60 doctors and there are 30 hospitals, right? We would do 60 doctors per hospital times 30 times 0.67. And that would give us 1,200. So 1,200 doctors would have children. Okay, so it's an estimation problem. Not too bad. I think it's just straightforward. It's very subtly made harder just by the fact that the hospital we're serving has 30, but then the average hospital has 60. And we do 60 times the 30 hospitals to find the total population. And then we're given 33% don't have children, so we have to find the percent who do have children, which is found by doing 100 minus 33. So if you have questions on this one, let me know, or on any of the other ones. I'm also doing videos in the future with more questions per category that you can be on the lookout for. And remember, I have done others, right? Probability and conditional probability, and one on evaluating statistical claims, and more will come. If you do the core classes, you'll really understand every type of question that the SAT will give you. Okay, so I'm building that out. Like I showed you in the beginning with the Substack, like post with all the types that I'm filling in bit by bit. If you have questions on anything, as always, feel free to ask me. Otherwise, I hope it's sunny where you are. And if it's raining, I hope it's cleaning your windows and watering your plants. Bye.